This is a video on Edexcel C2 Chemistry, topic 1. Just going to talk through the periodic table, atomic structure, and a few ideas about that area. So, topic 1, atomic structure and periodic table, starts talking about the periodic table and a guy called Mendeleev, Dmitry Mendeleev, and he came up with the idea of the periodic table. First, he sort of arranged the elements that he knew about at the time in order of their relative atomic mass. So that's the mass of an atom compared to that of carbon-12. He realized that the physical and chemical properties of the elements were related to their atomic mass in a periodic way, and therefore arranged them in groups of elements with similar properties that fell into vertical columns in the table. This is part of this table here. These seem to have similar properties. So as they fell into certain groups, they seem to have certain properties. Sometimes this method of arranging elements meant that there were gaps. So you can see there's a gap over here. There were many other gaps as well in the periodic table. But instead of seeing this as a problem, he realized that actually that there were elements there that just hadn't been discovered yet. So he was able to work out the atomic mass of the missing elements and therefore predict their properties. That's the key thing. Mendeleev was able to predict the properties of elements that hadn't been found yet. When they were discovered, Mendeleev turned out to be right. So for example, he predicted the properties of an undiscovered element that should fit below aluminium in the table. So you can see that there, this is over it. When this element, gallium, was discovered in 1987, its properties were found to be close to what Mendeleev essentially predicted. Two other predicted elements were later discovered, and that is what essentially led to credit for Mendeleev's organisation of the periodic table. So the modern periodic table is shown in the diagram below. Diagram to the left. The left-hand side of the table, remember, is that's the non-shaded part. They're the metals. The right-hand side, they're the non-metals. So non-metals on the right, metals on the left. Elements are arranged in order of increasing atomic number. So it's no longer by atomic mass, but this time by atomic number. So you've got columns going this way and periods going this way, or groups or columns going this way, and periods or rows going across. So elements are arranged in order of increased atomic number in rows called periods. Elements with similar properties are placed in the same vertical column. So again, the same idea, same vertical column, same group if they've got the same properties. So let's talk about the atom itself. So you should be very familiar with the atom by now. It comes up in P2 as well. So you've got the nucleus in the middle, protons, neutrons, electrons around the outside. Electrons negative, protons positive, neutrons neutral. The relative mass of these is a proton is 1, neutron is 1, and electron 0, sometimes known as 1 over 2000 or 1 over 1730, I think it is, or 1760, but very, very small is what you need to understand for that. So the electrons are around the outside in shells, and atoms of a given element have the same number of protons in the nucleus, and that's what makes them unique to that element. So carbon will always have 6 protons. Lithium will always have 3 protons. Okay, the number of protons changes, so does the element. So if you lose the proton, you've changed the element you actually are. Atoms contain the same number of protons and electrons, so there's no overall charge in an atom. So the same number of protons as electrons. Okay, so what that actually means, so it's got 2 protons here, 2 electrons. So because they have opposite charges, and because there's the same number of them, the charge cancel out to make sure it's a neutral charge. So the atomic number is the number of protons, mass number, number of protons and neutrons, and the relative mass or relative atomic mass is the mass of an atom compared to that of carbon-12. So if you wanted to find out the number of neutrons in an atom, you take away the atomic number from the atomic mass. So atomic mass, take away atomic number, gives you the number of neutrons. Remember, the number of protons and electrons are the same, so if you've got 6 protons, because that's your atomic number, then you must have 6 electrons. So I'll just go to it too far now. Isotopes. So, there we go. So if 2 atoms have the same number of protons, but they have different number of neutrons, they're called isotopes. So different isotopes have the same atomic number, same number of protons, but a different mass or nuclear number. A different number of protons and neutrons. This means that the relative atomic masses of some elements are not whole numbers. So for an example, chlorine is 35.5, and I'll go through why that is in a second. What you need to actually look at there is the relative abundance. You can calculate the relative atomic mass of an element from the relative masses and abundances of its isotopes. So here's an example here. If you've got chlorine, sorry, I skipped a bit too far. If you've got chlorine 35 and you have 3 of those, and you have chlorine 37 and you have 1 of those, what you do is you do 35 times 3, add 37 times 1, and the whole of that answer divided by 3 plus 1, so in other words 4. Okay, so this number here times this number here, add this number here times this number here, divided by these two numbers added together. What that tells you is what the relative atomic mass of all the isotopes is. Usually they don't come out as easy decimals. So this one is lucky it comes out as 35.5, but usually they don't come out as easy decimals, and normally you round it to the nearest 0 or the nearest 0.5. So if you're ever asked to figure out the percentage of an isotope that you have, that's how you do it. So relative mass of the isotope times relative abundance, added to the relative mass of the isotope times relative abundance, and all of that divided by the total relative abundance. Right, electron configuration. So electrons are arranged in shells in the atom, just like I said before. So the first shell can only contain 2 electrons. The first shell is 2 electrons. Each shell after that contains up to 8. You only move on to the next shell if the current shell is complete. To calculate the number of electrons, you need to look at the atomic number. So that's how you calculate the number of electrons, same as the number of protons. The atomic number tells you the number of protons. At an atom, the number of protons is equal to the number of neutrons. So number of electrons. You know that. For example, carbon has an atomic number of 6, so it has 6 electrons. This means 2 electrons in the first shell and 4 in the second. And you've got some examples here to help you out as well. So that tells you the way in which you write that out is 2, 4. So like this one is 2, 7 because that's 2 and then 7. That's how you write that. And this is 2, 8 because that's 2 and then 8 in the next shell. So here's some common configurations. You need to be able to do the first 20 elements. So the number of electrons in the outer shell is the same as the group number. So carbon has 4 in the outer shell, it's in group 4. Okay, remember groups are the columns and periods are the rows. So this tells you what group is actually in. The number of shells tells you which period it's in. So there's 2 shells, period 2. 7 electrons in the outer shell, group 7. 8 electrons in the outer shell, group 8. 2 shells, period 2. Okay, straightforward as that. 3 shells, period 3. 1 electron in the outer shell, group 1. Straightforward. Group by the group is by the number of electrons in the outer shell. The period is by the number of shells. As easy as that. And that's the end of this video on topic 1.